So we will be transforming these objects using dilations. Dilations. You may have heard of getting your pupils dilated. Some of you maybe that have some eye issues have had to do that before. It's always kind of weird. Well, what happens to your pupils? They get big or small, right? Or both, actually, right? Okay? They're changing size. That's what we're going to be doing now with these polygons, is changing the size of them. Okay? This type of transformation is not an isometric. Okay? Like the translation is, or a rotation, or a reflection. Okay? Those all keep the same size, shape, angles, everything stays the same. On a dilation, it's going to get bigger or smaller. Okay? Here's my best picture of what I'm trying to do is a dilation here. Okay? It's kind of hard on a, two-dimensional to necessarily show this, all right, but you kind of get the idea. The blue one here, the blue little triangle, was my pre-image. Okay? The little blue triangle was my pre-image. And what I did was I dilated it with a scale factor of 2. I dilated it with a scale factor of 2, or a factor of 2. What is a scale factor of 2 going to do to that little blue triangle, Kyle?
Alright, so every unit that it moves, wouldn't the other one move too?
Yes, I believe that. I'm not quite sure what you mean by move.
So the bottom side, how it's 2, and then the red one's 4?
Okay, so yeah, I see. For every unit of length on the small one, you're multiplying it by 2, or it's worth 2. So because that's 2 units long, this one's going to be 4 units long. Is kind of essentially what you're saying. Yeah, good, Skylar.
In the last chapter, you said when you enlarge something, it just changes the size. So wouldn't the angles be the same?
Correct. It would be similar. The angles would be the same, but the size is not. The lengths are not. The lengths are all double in this case. With the scale factor of 2, the lengths would all be double. And actually the area then is double squared, or 4 times the size. Because the area of this triangle would be 2 times 3 is 6. Cut that in half would be 3. 4 times 6 is 24. Cut that in half is 12. So this had an area of 3, that had an area of 12. So the area is 4 times bigger, even though the lengths were just 2 times bigger. Which that's the way it always works, because areas are square units, squared. Alright? So a dilation is just going to take something and make it bigger or smaller. What would the scale factor have to be in order to make the triangle smaller? Nope.
0 to 1.
Something between 0 and 1. If you multiply something by a half, doesn't it get smaller? Yeah. If you multiply something by 3/4, it gets smaller. What if you multiply something by 1.5?
It gets bigger.
It gets a little bit bigger, right? Multiply something by 2, it gets bigger. 3, it gets bigger. 4. So any number bigger than 1. If your scale factor is a number bigger than 1, your new image is going to be bigger. If your scale factor is between 0 and 1, okay, it's going to get smaller. Yes?
What if it's negative?
We aren't going to have a negative scale factor. It would actually take the image, the way we're going to do it, it would take the image and also move it into a different quadrant, potentially, or kind of reflect it in a sense. Okay? But yeah, we're going to keep the scale factors to positive numbers, but yeah. All right? So this is an example of a dilation. It's also kind of like, when you put an image on a Word document and you want it to be bigger or smaller, how you can click on the corner and drag it in or drag it out, and it stays the same shape, but it just gets bigger or smaller. That's in a sense what a dilation is too. It's like there's a little rectangle around this triangle, and I drug that out, all right, to make it bigger, and it became the red one there. Okay? Now, the math behind it is simple. Look what I did. The scale factor was 2, so look what happened to all the coordinates. Multiplying by 2, times 2, times 2, times 2, times 2, times 2, times 2. That's that easy. You're just multiplying them all by a number. Okay? So that's an example of a dilation. Another example of a dilation, I want to draw it out for you. So we don't even need a grid to necessarily do this. I know there's one up here obviously right now, but I'm not even really going to use it. So, on a couple of the practice problems you guys are going to have, they're just going to give you a shape, right? I'll just kind of do a trapezoid here. All right? They're going to give you a shape to copy. So what I'd do if I were you is I'd lay my piece of paper right over top of this shape and just copy it onto your, trace it basically onto your sheet. So they're going to give you a shape, all right? And I'll label them A, B, C, D, all right? Then they're going to give you a coordinate that represents the center. All right, I'm just kind of going to randomly put it right here. Okay, so I'm going to call it J. J is my center. And then they're going to give you a scale factor. They'll say like K equals, I'm going to use 2 again to make it a little bit bigger. Hopefully I don't run out of space. All right, so the way you would do a problem like this, if J is my center, okay, so I want the center to still be here, but I want to scale this thing up by a factor of 2. Basically what I'm going to do is I'm going to double the length from the center to each vertex. So from J to B, that's 15 centimeters on my meter stick here. So I'm going to take 15 and I'm going to double it to be 30. So it's going to be right up there. Hopefully I got room. J to A is also 15. So that's going to end up being right here. J to D is 12, so I'm going to double it to 24. And J to C is 24. I'm going to double it to 48. Okay? So now, I just did a scale factor of 2 with that red image. And then this would be D prime, this would be C prime, this would be B prime, this would be A prime up there. Okay? And I didn't even use coordinates to do it. I just used a ruler. Basically, I made every distance twice because my scale factor, they use K a lot of times as the variable to represent the scale factor. They use is 2 in that instance. Yeah, Skylar. If you don't have a ruler yourself, maybe just use the edge of a piece of paper or something, to kind of make a little mark on how far away it is, or do your best on that. All right. If you're working in here, I have some rulers, obviously, that we can get out. So there's another example of a type of problem. I won't even give you coordinates. It'll just say, okay, I want you to double it. Here's the center. I want you to double the distance to each vertex. So any questions you see on a problem like that? It's just getting you to understand scale factor. If the scale factor is bigger than 1, the object's going to grow. If the scale factor is smaller than 1, the object's going to shrink. Okay? So that's an example of a scale factor. Oh, here's the one we did in the other class. So I drew a rectangle, A, B, C, D, and I had H was my center, and I had a dilation of 1/2. So what happened to it?
That's smaller.
It got smaller, right? The distance from H, my center, to B, I cut that in half, so there's B prime. Cut that in half, there's A prime. Cut that in half, there's D prime. Cut that in half, there's C prime. Drew my new object there. So that blue one, A prime, B prime, C prime, D prime, there's an example of a dilation with a scale factor of 1/2. You guys kind of understand the dilation, what's going to be going on? Okay. The last thing that you'll have to do is something potentially like, yes, sorry, Kim. Okay. The last thing we're going to do kind of on this now is we're going to put some of these transformations together and do multiple transformations to a given point. All right? So it's called a composition of transformations. It's going to be more than one transformation. For instance, okay, here are my two transformations. The first transformation says to take any coordinate on the coordinate plane and do this to it. Well, what does that mean? What's that going to do to it? We've done this. Move it to the right 3 and down 2. Okay? So this transformation says to take every coordinate and move it right 3 and down 2. Or in other words, add 3 to the x value, subtract 2 to the y value to get your new coordinate. But then it says, after you do that transformation, to dilate it with a scale factor of 2. Which basically just means to take it and multiply it by 2, right? So, if this were an image, if this were a triangle, okay, so if I had a triangle, it wants me to move it to the right 3 and down 2, and then it wants me to do what to it? Dilate it by a scale factor of 2, so double the lengths of all the sides.
So you'd move the center of it and then dilate it?
No, basically, like let's say I actually had 3 coordinates here to represent some triangles. So let's say I had coordinate A, coordinate B, and coordinate C. Alright, we just did it with one coordinate because we were running out of time. Alright, so you could plot these 3 points to make a triangle, right? Yeah. Then I want you to move that triangle to the right 3 and down 2. Well, just take all these coordinates and do what to the x value? Add 3, so that would become 1, and then subtract 2. 4, right? Add 3, so 7, and subtract 2. 1, right? See, you with me? Yeah. Then, dilate it with a scale factor of 2. Yes, to using the origin as your center in a sense. So really, all you got to do is what to these then?
Multiply them by 2.
Multiply them by 2. So B prime then would be at 2, 8. C prime would be at 14, 2. So A prime, B prime, C prime would create a new triangle that would be this triangle moved right 3, down 2, and then made twice as long.
Okay.
Does that make some sense? Okay. So that's really all that dilations are going to be. Okay. Here's the biggest thing I want you to understand. There's 4 types of transformations. Rotation, reflection, translation, dilation. Okay, that we've had so far. 3 of them are isometrics. 1 is not. Which one is not? Dilation. The other 3 are isometries. What does that mean?
They don't change size.
They don't change size, shape, angles stay the same, length stay the same, okay? Alright, your assignment is page 629, number 2, number 7, number 14, number 21, number 22, 33, and 34.